Welcome back. So I'm here with an example one on simplifying this complex number with an exponent. So guys, here we have an exponent 10. Now there's few ways of actually simplifying this. We want to finally simplify to an a plus ib form where we can clearly see the real part and the imaginary part. So guys, one of the ways obviously would be to kind of write it out 10 times and then keep distributing and multiplying. But guys, you can see that is going to take us a lot of time and it's not a convenient or efficient way of doing things. But there's other way that can be really more quicker and more convenient for us. Guys, that way has to do with this theorem, de Moivre's theorem, where if we raise a complex number to the power n, then what happens? You just raise the absolute value to the power n, then you multiply that power to the angle. Okay, so keeping that in mind, guys, we can use this theorem to simplify this so that we can get the real part and the imaginary part. Guys, before we can start using that theorem, one has to first convert this or transform this into the trig or a polar form. So let us start with the first step, which is to transform this into the polar form, and then we are going to use the theorem. So in order to simplify this into or transform this into the polar form, first I'm going to write this as radical 3 minus I is my complex number, identify my real part, which is radical 3, and my imaginary part, which is going to be negative 1 because there's an invisible 1 here. Based on this, guys, I'm going to first plot this complex number. It will be radical 3, negative 1 will be somewhere in the fourth quadrant. So let's say it's somewhere right here, radical 3 and negative 1. And then I drop a perpendicular. Guys, we have been already doing it so many times. So this is 90, this is radical 3, this is negative 1. And keep in mind, we always measure the angles with the reference side and it's always counterclockwise. So this is going to be my angle theta. For simplification purposes, we also sometimes think of this as theta, but we know like actual angle theta is this angle right here. Guys, first of all, we got to start by finding the r, the absolute value, which is basically finding the hypotenuse of this right triangle. Guys, it's simply r equals to square root of the side square, radical 3 square plus negative 1 square. If I simplify this, it's going to be square root of 4, which is just simply 2. Once I have the absolute value, which is the distance from the origin, how far is the complex number from the origin, which is given also by this r. So r is positive 2. Now we have to go ahead and find the theta. To find the theta, I'll start with writing the cosine of theta. Cosine of theta, we know, guys, for this case is going to be x over r. It's the ratio of x over r. X is radical 3 over 2. And then sine theta is y over r, and y is negative 1 over positive 2. Guys, we already know it's in the fourth quadrant. So now I'm going to look at my unit circle, and from the unit circle, looking at the unit circle and looking at these two values, we can clearly find or see on the unit circle that the angle that satisfies both these conditions is going to be 330 degrees. So that's my angle, that is my r. Let us go ahead and write the equivalent form in the equivalent form of this. Sorry. First, I'm writing the equivalent form of the piece inside the parentheses, and then we're going to raise it to the power 10. So the trig form for this function, this complex number in the standard form is going to be 2 times cosine of 330 plus I times sine of 330, sine of 330 degrees. Okay. Guys, this is my function, this is my complex number transformed into the trig form, and now we have to raise it to the power 10. So guys, raising this whole thing to the power 10, again, one of the ways would be to write it out 10 times and multiply, but that's not something we want to do, because if we would have liked to do it, then we could have straight away done it for the first piece, like right away with the standard piece. But guys, that is a lot of work. We don't really need to do all that. What we can do is we can quickly use the de Moivre's theorem right here. So with this theorem, we just have to raise the 2 to the power 10, because that's exactly what it is saying. Raise the absolute value to that power. Here n is 10, so I'm going to raise the 2 to the power 10. And what do we do with the angles? You just multiply the angles with the exponent. So in this case, it's going to be cosine of 330 times 10. Guys, that's exactly what's happening here. N times theta. Here n is 10, so it's 10 times 330. And then plus same thing, I times sine of 330 times 10, and that will be the first step from here. Guys, 2 to the power 10 is I think 1024. Let me make sure that I have the same thing here. Yeah, 1024. And then this is going to be cosine of 330 times 10 is 3300 plus I times sine of the same thing, sine of 3300. Guys, at this step, we still want to simplify because we want to get it finally in the standard form. To get it in the standard form, guys, what we have to do is we have to figure out the value for cosine of 3300 and sine of 3300. Guys, there's few different ways of doing it. One of the ways is to, and the way that I like to do it is, guys, I take this number and I divide this by 360. So let me see what I have in my notes. So when I divide it from 360, clearly this is not completely divisible by 360, but I go to the nearest integer. So here I was able to go up to, let me see what I have here. So I got 9, okay, I got up to 9. So that means what I got here was I divided this by 360. So when I starting from here, we always start from here. So going around 9 times, finally I reach back here, and then I had to add 60 more to get to 3300. So going 9 times around the unit circle in a counterclockwise direction, finally I reached here and I got 3240. Okay, when I went around this unit circle 9 times. And then finally to get to 3300, guys, I just had to go 60 more. So this would give me finally, like, once going around 9 times, and then the extra 60 degrees to get to 3300 degrees. So basically 330 degrees is coterminal with 60 degrees in the first quadrant. Okay, so if it is coterminal with 60 degrees in the first quadrant, all I have to do is, in my unit circle, I have to look for the values for cosine 60 and sine 60. So first of all, I like to write this as cosine 60 instead of 3300, and then plus I sine of 60 as well, because these are coterminal angles. Guys, if you have other way of actually getting the 60 degree or this coterminal angle, you can do that. Sometimes people like to keep on subtracting 360 so that then finally they can get up to that 60 or whatever that coterminal angle is. But I like to divide, and from there I like to find out my the reference angle. Okay, from here, guys, this is going to be 1024. Looking at my unit circle, I get cosine of 60 is 1/2, and then the sine of 60 is radical 3/2. Okay, we can still simplify a little bit, which is just distributing that 1024 with both of these. Guys, I need some more space to finally write the final answer for this. So I think we can get rid of this here. We don't really need this. We already figured out the R and the angle, so we don't need this anymore, and I can use this space now. So guys, I have 1024, and when I multiply, so first let me rewrite this, plus I times radical 3/2, and I got to distribute this. What do I get? 1024 times 1/2 is going to be 512, and then same thing here, 1024 divided by 2 is 512, so it's I 512 radical 3. So this is my standard form, A plus IB form. Now if you have to identify the real part is going to be, real part A is going to be 512, and the imaginary part, which we usually refer by B, is 512 radical 3. So we were able to simplify this expression to a simple standard form where we can identify A and B. Guys, what we did here was we did not try to just write it out 10 times and multiply. That's too much work, and we don't really need to do all that. What we did was we transformed this inside the parentheses piece into a polar form, and then we use the Moivre's theorem to actually simplify this. Guys, at this step, please make sure that if this is greater than 360, then one has to kind of find the coterminal angle, which is going to be visible on the unit circle. And once we are able to figure this out, that the coterminal angle for this big angle is going to be 60 degrees, then we can look at the unit circle and fill in these values, simplify, and that's what we get. Okay, guys, this is example 1. I want to show you one more example for using this theorem, and then we're going to move into some new concept. Till then, guys, take care, keep practicing.